Hi, everyone. A very good evening to all of you. It's great to have you this Friday evening for live session on another very exciting topic within the domain of data sciences. Today, we have with us our expert, Mr. Sarveshwaran. Sir, can I have you on camera, please?
Hi.
Hi. Thank you so much for your time, and we are looking forward to a lot of insights. But before that, let me quickly introduce Odin School and then introduce you, and then I'll hand it over to you. Odin School, like most of you know, is an upskilling platform, and we focus on helping people better their careers. We upskill people in new age technologies, and then the training and the placement assistance. With all of that, we have seen our learners make amazing career transformations. So that is what we are. We specialize in 6-month boot camps on data sciences, full stack software development, and in the next few months, we'll also be coming up with a few other new age technologies. But today, it is all about data sciences. It is all about the developments that are happening in this domain. Mr. Sarveshwaran is data science specialist currently with LTIMindTree, and he comes with a lot of experience in the data sciences domain. Today's topic is very interesting. How do you extract information from NLP? So I will leave it at that. I will let Sarveshwaran take us, dive deeper into this topic and help us understand what it is all about. Looking forward to a very exciting session. Sarveshwaran, over to you, please.
Sure. Thanks, Shruti. And good evening, folks. I welcome you all to the interesting session on the information extraction using NLP techniques. Okay, let me share my screen. All right. So, okay. So, what is information extraction? So, any thoughts? So, how do you put in chat? Okay. So, so here the information extraction is a wide topic. So, after the rise of the GPT models and all these things, so the text is being shown more importance in the current world, right? So, how and text processing is done? How can we make an informed decision with all the documents that's uploaded, right? How can we extract the entities? There are various different applications in the information extraction. So let's see what is an information extraction, and let's go through it. Okay. So here, so the current the tools that we are going to use is the Python app. I have working notebook. We can also understand what is an part of page, what is an information extraction using Spacy. And I'm using a Jupyter notebook for the today's session. And I've also taken an example, the real-time example, the resume shortlisting using NLP. I've also showcased how and resume can be shortlisted using the NER techniques. Okay, so here I'm going to use NumPy, Pandas, Spacy, and for plotting all the Seaborn, Matplotlib, and Scikit-learn. Okay, so so before here, so let's understand text. So what is a text? So for us, it's the text is coming from a document, right? So what is a text for a mission, right? So what are the different use cases that's revolving around the text? So the text can be the text processing can be taken into 3 different processes: lexical processing, syntactic processing, semantic processing. So what is a lexical process? So firstly, we convert the text into words, and depending on all your application needs, so they are converted into either sentences, paragraphs as well, right? So not only converting to words, it can be converted into sentences and paragraphs. Say, for example, you receive an email. It has a word such as lottery, prize, or luck, right? So then the email is represented by these words. It is more likely that email is going to be in spam email. Okay, so we have a lot of other words. We don't want the email inbox to be spam, right? So the first use case, we are going to take a specific word, and we are going to look up for that word. If there is that if that email contains the word lottery, the price, or luck something, right? In general, the group of words that is contained in a sentence, and it gives an idea what that email is or what that sentence is. We are breaking in, the email into smaller parts, into sentences or in paragraphs or in words, right? So here it does not look for the syntax. It just looks for the word. That word is present. That email is classified as in spam. The classical use case, right? Very classical use case. Now, what is the advancement to it? We do a syntactic processing from lexical analysis or lexical processing. What is a syntactic processing more advantage than lexical processing? Here in syntactic processing, we extract the meaning from the sentence by using the syntax of its word, syntax of that sentence. How do I extract the syntax? I extract the sentence using an part of speech tag, POS tag, very famous. What is in part of speech? Noun, verb, adjective, determiner, right? So adverb. There are so many different part of speech. And another one is the named entity recognition, very famous use case nowadays. So if I have number of documents in it, so there are a lot of noise that is present. The unwanted words. I need to extract only the useful information from all the documents or in a book or in a set of text. How do I do that? I extract using a named entity recognition. By understanding the part of speech, the named entity recognition is done. I'll also showcase an example where we have in real time we have done resume shortlisting using NLP. Right? How a named entity recognition has been used, and we have done a beautiful project around the syntactic processing. Right? The resume shortlisting using NLP. And the last step here is the semantic processing. Right? So here in the syntactic processing, in the lexical processing, if I have an example, my cat ate its third meal. And there is another sentence. My third cat ate its meal. Syntactically, these are two different sentences. If I had to use a lexical processing, it doesn't know the cat ate its third meal or my third cat ate its meal. They both are same for lexical processing. When I'm going to use a syntactic processing, it knows what's a verb. It knows what's a noun, what is a noun phrase. So it can actually find the difference between the first sentence and the second. Right? Ram thanked Shyam and the Shyam thanked Ram. The classical example. Who thanked whom? Shyam thanked Ram and Ram thanked Shyam. These both are two different sentences. Lexical processing cannot distinguish between these two different sentences. If I'm going to use in syntactic processing, it knows the difference between who thanked who, right? So it knows Shyam thanked Ram is different than Ram thanked. And the last is your semantic processing. It's more advanced. We are going to use it in a topic modeling, the question answering system, the chatbots, the machine translation, the sentiment analysis, the applications keep on extending. Semantic process. Semantics is the most important, the trending topic nowadays. Right? What is a semantic? Right? Say, for example, someone asks, who is the Prime Minister of India? Right? So we are using an Alexa, we are using an Siri, right? Some voice assistant. We're asking who is Prime Minister of India, right? It replies with Narendra Modi. So if you're going to twist the question, who is the PM of India, right? It should have the capacity or capability to understand that Prime Minister is equal to PM. How does it happen? We cannot create a lookup table for all the different the acronyms or the short forms. It should create a lookup table on its own. How does it happen? It happens on the basis of your semantic processing. King and queen, right? There is an example, right? So The queen is simply the female version of the word king, right? If both these words are clubbed together, they are coming under the upper class, under the monarchy or a kingdom, right? So the queen is nothing but a female version of the king. The female and the queen or the king are not same, right? So it should understand the semantics present there. What is the meaning of that word is obtained using the semantic analysis. That's where your famous examples like machine translations and the chatbots, like I mentioned, right? So the scope of the semantics is far advanced than your lexical processing and your syntactic processing. Okay, let's go one step further. So what is an information extraction? So what is information extraction? And then we'll get into the pipeline. What is an information extraction? So we extract the structured data from the unstructured data. To put it in very simple and in layman terms, we have an unstructured data or a semi-structured data. So we need to extract the useful or the important information or the structured information from an unstructured textual data. The famous example is your named entity recognition, NER. Most of you should be aware. So named entity recognition. What is an entity? Who did that? When? Why? So there are a number of entities. Say for example, let's take an example. I have a number of examples. Let us go here. Just so what is an entity to make you understand? Say for example, I have so this is an the example from your resume shortlisting, right? So I have various different entities such as the name, location, email address, your contact number, your degree, the institute, skills. So out of all the information that's present in that you have given in your resume, which interests me more? I, after all, need your name, location, email address, contact number, what is the institute, skills, and years of experience, right? So I need from your 1, 2, 3 pages or n number of n pages of your resume, I need only these information to do an initial screening, right? I cannot go through all the hundreds of resumes, right? So this we have created, right? So to do an initial screening process, because we see nowadays a lot of technical managers are getting involved for data science resume screening, right? Yeah. So what happens is it goes beyond the scope of an HR, right? So the HR may not be able to take a closer look to all your skills. Right now, the technical managers are getting involved. So the role of a technical manager is not to shortlist resumes, to spend a lot of time in your resource management, all those things, right? So they are getting paid for a different reason, right? Now their scope is changing. So how can we make a smarter use of your this information, this NER, and we can make an informed decision, right? So we can extract all these entities from the resume, right? Maybe I'll explain this in detail. Okay. So I'm just explaining what is an entity. Okay. So we extract all these entities. We convert into a JSON format. Once it is converted into a JSON format, and I vectorize all your words, the text. To do any modeling, your text should be vectorized. You can use an TF IDF, term frequency inverse document frequency vectorizer, the count vectorizer. There are so many different vectorizers. So the very famous is TF IDF vectorizer. You convert into vectors. In another and the other side, you also have your resume. Your resume is also vectorized, and I do a cosine similarity match, and I can get your rank order, right? So, and then for every resume, what is the percentage match to the job description? Right? This is one example. Maybe I'll go one step by step. So I'm just trying to give an example of what an information extraction is, right? So so after all, the information extraction from all the semi-structured data. What is in semi-structured data? JSON format is in semi-structured, and the various unstructured data. You convert the data to a structure. Examples from your news stories, your scientific papers, your resumes. You extract only the useful information that is of your own. How do you do the information extraction? Right. So I do the information extraction using this 5-step process. Right. It's easier said than done. But yeah, so we first start with the raw text, and we do the sentence segmentation. Once I do the sentence segmentation, right? The basic pre-processing goes like this, right? So what is the word tokenization? We also do the POS tagging. So I break down all the sentences, the raw text into sentences. And then once I have broken down the raw text into sentences, and I do the tokenization. So what is a word tokenization? I break each and every sentence into different tokens, into a list of strings. And the third step is I'm going to use a part of speech tagging. I'll show you how the part of speech tagging is done. And then I do an entity detection. What is the entity detection? Like I showed you some time back. Out of all the information, I need after all the 10 different entities, the name, institute, the years of experience in the resume shortlisting. I identify the entities from the resume or from your newspaper or from your research paper with the help of your part of speech tag, POS tags. And then I have chunk sentences, and I have a relation detection, and then I find the relations. This is how the information extraction pipeline is. So any questions so far? Sneha, so how do you see the questions? You put it here.
Sarveshwaran, so there might be some questions coming in because this is being live streamed on YouTube and LinkedIn. So okay. Any questions come up, we will
sure
inform you.
Sure. Right. Okay. Now the models for information extraction is either in rule based or in probabilistic based. So in rule based, we use in regular expression based rules, right? So I hope you know what is in regex. So rule based. So we have various different rules. So we have in the quantifiers, your wildcards, right? So on basis of all these rules, we extract the entities, and again in chunking. On probabilistic models like in unigram, the bigram, the naive-Bayes classifier, or in conditional random fields. Right? There's a wide topic, so I've taken few different examples. I wanted to showcase what's in part of speech tagging is, and I also wanted to showcase how an entity recognition is done, and basic few examples around the NER. So this is the agenda that I have set. Okay, so if you have to go through all this, the conditional random fields, the chunking, it's much beyond the scope. It takes a lot more time. Okay. Okay. Now, before I go here, let me go through the notebook. Okay. So I import the libraries, import pandas as PD, and NumPy as NP, and import to OS. So these are the three different the libraries that I've used. Okay. So how do we identify the product features? First of all, there's an example for a part of speech tag. How do I identify the part of speech? Right. So the battery life, the camera quality, the value for money, the face recognition, the battery backup, So there are so many different things. So in the first sentence, I love the screen resolution on this phone. The battery quality of the phone is great. The display is pathetic. Okay, so I have 3 different sentences. So let's do an part of speech parse, and we see if we can infer any patterns out of it. So here for this exercise, I'm going to take an example from I'm going to make use of a library called as Spacey, very famous library, the Spacey. And so these are all models, the transformer based model. These are all pre-trained models. How do I load the pre-trained model? I use an spacey.load n core web SCM. Right? I use this n core web SM English, and it is pre-trained, right? So it's a very big library that's pre-trained, and I'm saving it inside an object NLP. As you can see, the star indicates that the cell is still running, right? So it's just loading this in big model. Okay, now you can see that it has loaded. Now let me take NLP of cent1. Right, so how do I extract the entities? For the document 1 here, for I in doc 1, now I want to print the I dot, what is the text and what is the part of speech. I dot. Okay, now you can see here I've used this pre-trained model, and for this sentence, I love the screen resolution on this phone. I'm extracting, I'm tagging, I'm doing a part of speech tag for each and every word. I, proper noun, loud verb, the determiner, screen noun, resolution noun. Right, so I'm extracting. I'm tagging, so there's not an extraction. I'm just tagging. I'm doing a part of speech tagging. So the document 2 is equal to NLP of cent2. Similarly, what I'm going to do for I in the document 2. Now I print I dot text, comma I dot POS. Right, so I'm just understanding. Similarly, I'll do for the third sentences. So here we can understand which are the important features which has a part of speech tag as noun. Okay, so the display, the screen. So here the product features such as some screen, battery, the display. So these are all tagged as noun. Right. So, so further extension to this, what we can do? I have known the important product features. So the important product features, right? So we can, so we know, right? So the important entities, the important entities are always tagged as noun and proper noun, right? If we want to extract the useful information, we can simply extract the noun from that sentences or the document that we have as an initial stage, right? So important product features such as on screen, display, battery, speaker, these all have a part of speech tag as a noun. Right? The next step would be we can find the frequency count of all the nouns in our data. Then by looking at the top n nouns, we can find what is this product features that the people are talking about. And extension to this, I can check an hypothesis on the real world data. So what is that? So if I'm going to extract all the tweets about an Apple product, right? Or any movie review that we want to do in a tweet, right, from the Twitter feedback. I extract all the Twitter tweets. Okay, there is a connection from which we can download all the tweets with given a hashtag Apple, hashtag the Android, whatever the hashtag you give, you will be able to download all the tweets. So once you have downloaded the tweets, you can do a part of speech tag of that now, and you can understand what is that people are speaking more about, and you can start doing a lot of exploration by doing some hypothesis testing and the sentiment analysis by doing the first step, by taking the first step of doing the part of speech tag. Okay, another example also I have taken. So here reviews data from the Samsung, right? So similarly, I'm making use of in core web here. Okay, so and so there are so many different reviews here. Now, yeah, so the Samsung reviews. Let's just look at the reviews. So every word is a line. Now let us just do that split. So this is where sometimes your local system is stuck even for a small data. So there's an example of it. Right? So it's in such a small data, your local computer is not able to support. Right? You can make use of Google Colab, the pro version of Google Colab, and you can make use of the GPU processors in the Google Colab. Right? So you can take Samsung reviews and split it how? Split it into each sentence 0 to 4, right? So I'm giving an escape sequence. N is a new line, right? So the escape sequence, new line. So I'm splitting with respect to a new line. Show me the first 4 the reviews, right? I'm just showing. So the indexing starts from 0. So I feel so lucky to have found this used phone online from someone who upgraded and sold this phone, right? So my son liked this one, and so there is a review. So very pleased. It works good, but it goes slow sometimes, but it's a very good phone. I love it. So once you have such a kind of text or feedback, you can do a lot of things. You can do a sentiment analysis. You can categorize. You can do a topic modeling. Again, you can think about this if you're working in an operations. There are so many tickets that's raised, right? So what are the current days people are doing is they are the tagging. What is the priority of the ticket? P1, P2, P3. Tagging of these 3 different tickets: priority 1, priority 2, priority 3. So you can automatically classify. Automatic ticket classification is an example. It's an extension to all this information extraction. Your POS tag, right? So you can suggest this the use cases to your organization also. So automatic ticket classification. And you can do a sentiment analysis, and you can route, if you are doing a topic modeling, you can route the tickets, right? If there is a P1 ticket, there are 10 different P1 tickets, right? Who is specialized in in a login issue? Say, for example, there's a login issue, right? Who is specialized to a login issue? We can automatically route that ticket, the P1 ticket, to the assigned person, right? So there are a lot of applications using this NLP, right? So will our hypothesis hold on real world data, right? So let's take the Samsung reviews and split and take the first one out of it. The review 1 is equal to review 1 is equal to NLP, or hold on, NLP of a reviewer. Okay, so let me tag it as R1. Now let's do NLP parse on part of one review in our data set. Right. Similarly, for IN R1, right? So there are so many. Let's take 0 to 10. Okay. So and then print I dot text. Okay, and then we put I dot POS. Now let's also add I dot lemma. Okay, now what have I done? I'm taking each and every word and I'm extracting a lemma of a sentence. What is a lemma? Any idea what is lemma? Or what is a root word? I convert every word to a root word. Right? I do not want to have the what and word, the verb, right? Have, having. See, found, find. It's converted to its root word. So this is done using two different words: the stemming and lemmatization. So the stemming converts every word to a root word on the rule-based format. Lemma accounts the part of speech tag and it converts it to its lemma. Right. So there you call as in stem words. Here you call it as a lemma of that word, the root word. Right. I hope I'm just making it clear. Right. So there are two ways of converting in word to and root weights. One is your the stemming method, and another is your lemmatization. Right. So the stemming just converts hard codes. It's in rule based, and it converts to its root word. And the lemmatization is an other technique. It makes use of the part of speech tag, and on basis of the part of speech tag, it converts the extended word to it lemma of its word. Okay, so here one thing that we have done more is lemma conversion to a lemma. Okay, now let's see. Okay, so for okay, it's an R1. I'm just converting it to an data frame, proper data frame, right? So the moment I make it to an data frame, so I can do a lot of things, right? So here it's all it's not an inflected word. These are all the straight form of word, right? So here and then I'm converting most frequent lemma forms of the nouns, the phone, the one lucky line. So these are all the part of speech which is tagged as a noun, and I'm just taking the lemma of that word. In sense, I'm just removing the inflection form of the word. What is an inflection form of the word? I have a word called as playing. I convert the playing to play. Right? I knock off that ing and I make it to play. Going, to go, driving, to drive. So it is. I don't want to have one word to be inflected in form. right? It is just for the grammatical sense, right? So I make use of the part of speech tag and I convert to the lemma of that, right? And then I repeat the same experiment in larger data set. Okay, so let's see how it goes. So it takes some time. Just hold on. So when you're working with image and text, so it's better to have an higher configuration systems, right? So I've taken very simple to 1,000 records, right? It is taking such a long time, right? So sometimes I have lost patience. So sometimes the models used to run for hours together, right? It will take 5 hours, 6 hours, right? So and then if we have to do a small fine tuning, and then I have to go back, right, and then do a small fine tuning, and then again wait for 5-6 hours, right? So that's where you can make use of the higher configuration systems. You don't have to necessarily invest in a new hardware. Make use of the cloud platforms. There are many cloud platforms nowadays, right? So you can make use of your very famous the Google Colab Pro. Very simple, very cheap, and there are some disadvantages. We can keep arguing in it, but if you're a beginner, if you're learning, right, so you can start making use of your Google Colab. And okay, so and then you can see, so if the part of speech tag is noun, right, so which are the words for the 1,000 sentences? The phone is the highest used. Time, battery, screen, and price. This is what people are speaking more in your feedback, right? So the moment I understand this, what is that my people are speaking more, I can make some informed decisions. The extension to it, like I said, in sentiment and the sentiment analysis, right? Automatic ticket routing. There are a lot of applications. So I can convert to a workflow. Right? This is a small experiment. I'll show a small demo that I can show it in a moment, right? So, so what will be the time to process all these reviews, right? So that's what. So it has taken so long, right? It will take a bit more, right? To process all these reviews, it is taking a lot more time. You can see to do this the review processing, it takes much more time than even, right? So the summary part of speech tag based rule seems to work well, but we need to figure out a way to reduce the time taking process of these reviews. So this is one time consuming way of doing it, a bit and back old school ways of doing it. Now we have very bit more advanced ways of doing it. Let's see. So another example I've taken. So I've taken a Samsung data, the same thing. How can we reduce the time taking? Very famous example, very famous library is your Spacey. I've used the same Spacey library to do the entity recognition or the entity extraction from all the different resumes. I give the text, I tokenize it, tag it, parser, named entity recognition, right? All this and it's converted to. And this is the pipeline here. You can see I just all these are taken from here, right? From the Spacey. You can see the text, the tokenizer, and the Spacey 3.0 was very famous. Now you can see there is a new version of Spacey, right? Just understanding the Spacey and by making use of this pre-trained model, you can fulfill most of the low-hanging fruits in the market. You can have so many different applications using this Spacey. Just go through this Spacey. Very fantastic library. I'm not promoting it, but I've realized it by using it myself, right? So you can see. So what all? It's very simple, right? So you can go here and you can select what is the pipeline that you want. You're talking to vec, tagger, parser, or NER. So you can go here and you can download. Wait a minute. So okay, so you can configure here and you can download the file. You can download the config file right away. Maybe I'll show you at last. I have the downloaded config file. I'm not getting it right now, but I have the downloaded config file. I'll show you how the config file will be. Like you do the hyperparameter tuning, how you pass the values to the model. So all these things can be done in the config file, and you can load the config file directly, right? And you can also do a custom based NER. If you do not want to make use of the pre-trained model and you want to custom train the model, you can take the pre-trained model Encode Web SM, right? So and you can do a custom NER here. Okay, so that is one thing that you can explore. So I load this model Encode Web SM, right? And you can see it's a bit more faster. You can see the time taken is 27. Okay, so we're using an so the time consumption you can see. So it's far more less time consuming than your traditional way of doing it when you're going to use a spacey library. It shorten the pipeline loading. Okay, so you don't have to use the parser or an NER. You just disable this too. Right, just by disabling this too, you can save a lot of time by using an Encode Web. So this is one simple thing. All this comes from experience, right? So I'm just giving it right away, right? If you just disabling this couple of the parameters here, so you can save a lot of time. So let's process all these reviews, and yeah, it takes much more time. I don't want to do it, but definitely by disabling these two, you can save a lot of time here, right? So and I can also do an analysis. What is battery, product screen, how much number of times it was used, most frequently used lemmatized words of noun, inform us about the product features people are talking about in the product, right? So there is different way when you write in feedback. It's not proper grammar, right? We write whatever we want to write, exactly, right? So I want to do the pre-processing so that I make all the feedbacks in a uniform way, right? I write it in my own way, my own slang, right? The people in US write in their own slang. The people in UK, they write in their own slang, right? So these products are having an international market, right? So I need to convert them to the root form, normalize, right? You do the normalization in the numbers. Similarly, you do the normalization for the text, right? So in order to process the reviews data faster, allows us the idea of enabling the model inferencing pipeline using the spacey loads command and disable some parameters like it should. I'll also show you a very interesting example and shortly. We have very less time, but anyway, I'll show it to you. You read the data again. Another example here. Okay, what is that people are speaking more? So we can use in simple heuristic, find out where the most common words that appeared before and after each mention of the product feature. So we use a regex pattern to extract the information, right? So how do you use that regex pattern? Right, so yeah, maybe I can go explaining. So the regex pattern, you have 5 important functions: match, find, the match, the search, the find all, the find iter, your substitute. So these are the 5 different famous functions that we use. And we use in famous the 5 quantifiers: the question mark, the star, the plus, and the MN operators. So these are the different quantifiers that we use. So basis of all these regex patterns, we'll be able to extract again, right? So extract the information from the text. The battery was great, right? So the battery was great. the prefix, keyword, and suffix. Right. So so these are the different quantifiers. So what is a quantifier? Question mark, the entity, the last keyword matches that the preceding character matches 0 or 1 of the preceding group. The star matches 0 or more of the preceding group. Plus matches 0 or more of the preceding group. Right. So again, MN quantifiers. So these are the different quantifiers that is present. So for example, and right. So again, the wildcards, the anchors, bit advanced in the regex. If I'm using an exponential mark here, so the string must begin with an use a dollar sign at last. The string must end with an right. So these are the different quantifiers and the wildcards on the anchors here. Okay. So see again here I can use. So here I'm using an regex based way of doing it. Now see here, I'm using an find all function. So out of 5 different functions I mentioned, match, search, find all, find item, and substitute. In that I'm using an find all function. So what is that function doing? It has a pattern. I have a pattern, right? So on basis of that pattern, I'm identifying what are the important words with respect to battery. It is there. The battery was. So in the first review, I'm taking that pattern, the battery was, and I'm checking for the number of times it is present. And I'm just taking the prefix of the word battery. And I'm taking a suffix of the word battery, right? So you can see how I can play around with the text. So I can do a lot of things with this text, right? So, so all these things are called as some meta sequences, right? So the meta sequences goes like this, right? Say for example, so yeah, so so again you have a lot of meta sequences. Yes, and capital S again here, small s, capital S, slash D, slash capital D, slash W, slash capital W, right? So if there is any white space present, right? If there is any white space present, white space that is present, or in other words, right? So if you are going to use in backslash the escape sequences, you'll use an escape sequence T, escape sequence N, escape sequence R, F, and V, right? So once you start learning this regex, so we have a short form for all these regex, we convert these to a meta sequence. If there is a white space present, I use a slash S. I use a capital slash and the escape sequence, and then yes, the capital S is to search when there is if there is any digit present, right? I want to extract the digit that is present. If there is any alphanumeric sequences, right? If there is an inverse set of alphanumeric, so these are some shortcuts. You call it as some meta sequences, right? So this gets too technical. So at a high level, I'm just using an slash S and small w, the alpha numeric sequence, and if there is a white space present, right? Like I mentioned, W, the alpha numeric sequence, and white space present. So it identifies the prefix and suffix of the word when there is a white space present, and then alphanumeric character, the alphanumeric sequence being present. So any text that you give, I can extract the useful information using the regex rules. These are all rule based. Okay, extract all the prefixes and suffixes of battery. Right, so these are the different places where battery is used. That battery life, the battery was, great battery life, removable battery for. So I extract the prefix and suffix. Right, so for every word where the battery used, I extract the prefixes, the, good, great, long. You can see the long battery somewhere it was present. Where it is. I've just taken few of it. Right. Here it is. That battery life. You can see life, and yeah. So all the prefixes and suffixes are stored here. I'm just taking few of it, just 5 of it. Right. Now you can see the, and there are yes. So these are all some words. These are all connectors. These are some grammatical connectors. So these are often called as some stop words. I do not want to use the stop words. Okay, I can delete the stop words. I need to remove the stop words. Right. So these are all the stop words. So there are an stop words library again. From the stop words library, you can download the you can use the stop words and you can remove the stop words. The prefix and suffix, I just remove the stop words, and you can see now what does that the battery say? Good battery life, great battery lasts, longer battery last, new battery doesn't, removable battery runs. So we can extract some useful information. What are they speaking about? My key entity. My key entity here is the battery. What are they speaking about my battery? Good battery life, great battery last. So they are giving some positive words. They are giving something, some useful information out of all these feedbacks. First I extracted the keyword battery, and I'm giving in prefix and suffix for that battery. And as an user, as an analyst, it gives me a very good insight. What are they speaking about my battery? I can make use of this regex, and I can do the similar thing for your screen, right? So screen touch protector, big screen size, great screen resolution, something they are appreciating, larger screen protectors, home screen quality. So they are with, I've just made, I've not got too detailed, I mean too involved analysis, just in basic. I'm just basing on the low hanging fruit, just by taking the prefix and suffix of my keywords, the key entities, the battery and screen. See how big you are getting some insights from the feedback. As a takeaway, you download the tweets from the Twitter, or you take your Amazon the product feedbacks, and you do a similar analysis just by taking few 2 or 3 steps into the regex and your spacey. We have achieved something, and one step towards your the sentiment analysis, right? I'm not saying this is all, but at least we have taken one step forward than the raw text that we were seeing. Right. So some very simple heuristics sometimes are very useful. I've done very simple. Regex can be life savers. Don't forget to use the simple text processing while trying to solve the not trivial problem. Right. So there are so many advanced techniques. So after the rise of all this GPT models, so this text has been the area of focus for all industry leaders nowadays. Right. Basic text pre-processing, even in basic text pre-processing, is not done in various different industries, right? So if you could have and taken stepping of foot in your organization, if you have text, if you have log, right? Say for example, all the logs, all the programs, all the applications that we have in log files. Take the log file, doing basic the text processing, put it in a dashboard, right? Hardly takes maybe for while you're learning, it takes much time. But once you have learned, it's hardly a 1 or 2 hour a day job, right? It can amuse your clients, right? So that's the power of the NLP, the basic text pre-processing. The Gen AI is a different thing altogether, the GPT stuff. But again, so the basic heuristic, the simple heuristics can do a magic. And let me simply go through the resume shortlisting, what we have done. We have taken all the different entities and have given the starting and the end characters. So there are various different tools that's available, and we have given the positions for each and every resume. What is the skills and the graduation year, right? The collecting the training data is one of the most time consuming and the complex thing here. So once we have collected the data, okay, so again I use the Encore web. I use a custom based custom NER, right? So I use a document format, right? Empty document, and I take all the annotations from the text, and I do the entities. I extract the entities, okay, and you can see the pipeline builds. It takes some time. This has taken a lot of time here. So while you can see in every epochs, these are all the epochs, E stand for epoch. So for every epochs, and I've given the initial learning rate as 0.01. So what is the F1 score? What is the precision for each and every entity that is improving? You can see the precision has improved. F1 score has improved, and I have saved that model. Maybe instead of that, I can go here, right? So there's a resume. You can see that what have I extracted, the degree, the institute name, all these are extracted, right? Again, I have the text data, and you can see, and I've evaluated the model, right? So in that, what are the entities that I have extracted? The name, the contact number. What is the precision recall F1 score for the test data that I have passed? The challenges that I faced was these were some entities that were lower in low case, and it was in smaller case. Right, all this again to be pre-processed, and I have a different working file. This is just for demo. I'm showcasing how the uppercase and then lowercase makes an impact. Right, and then we have done a lot of processing, and I've used an count vectorizer, and coming here, let me quickly, yeah. So what the model has, the final model has given us, right? So what were the F1 score, the precision recall for the model that is evaluated, right? So this was the first step, and later we have achieved, that is again in different system, we have achieved an with the over 100 and 150 resumes. So we have achieved an F1 score of close to 95%, right? So I was not able to get that, but by doing the same process here in this example, it was 85. So by retraining and doing some hyperparameter tuning, so we were able to closely reach to 95%. And this was how my final. So for each and every resumes, I can see the percentage match, and I can rank order the resumes, right? Rank 1, Sarvesh resume rank 1, right? So if I have 100 different resumes for one job position, I can rank order the resumes. So at least it gives my manager to start with the screening process, right? Instead of taking something at random, he can have an informed decision. Instead of taking from the 100 different resumes going randomly, go in this order, which has the rank 1 to rank 10. If this is not found fit, then right, I'm giving a hierarchy. I'm giving a rank for my managers and the HR professionals to look and make an informed decision. Right. So this is one example where NER is used. Right. So this is again, we have collected over 200 resumes. Right. Some data pre-processing. Right, remove the punctuation, remove the stop words, conversion to the root words. The conversion of root words is called the lemmatization or the stemming. Removing the extra space characters, So in the training in-ear pipeline, like I showed you, the data preparation, conversion to the SPACY format, creating the config file and the training data. Right. So this is how the model is evaluated, and this is what the final output that we have achieved. Right. So some real-time application I'm trying to bring. Right. So at a high level, so candidate resumes in various different formats. I do the entity classification, data segmentation, the tokenization, and the feature tagging. I convert the resume in the summarized format, like I showed you in the JSON format, and I do the feature recognition, feature extraction, and I vectorize it. So you know what is vectorization? The TF I get the term frequency, inverse document frequency vectorization, and I use in cosine similarity. The job description is here, and the vectorized. Okay, the job description again should be vectorized. Okay, this arrow mark should be here. That's a mistake. So this is one vectorized format, and the job description is also vectorized. I use a cosine similarity match to find the match between these two, and I rank order all these candidates. Right. So this was a fantastic use case that we have achieved using this in the okay, the real-time use case where we have achieved, and we are using it in, right. So this is one area where we have achieved it. All right, so I'm just taking in pause or in break. Do we have any questions? Or and so this is what which I had planned for this session. So do we have any questions?
Yes, so we do have a few questions. Probably give it 5-10 minutes. So first, one of the first questions is, could you talk a little about tokenization? What is tokenization? Could you repeat that, please?
Okay, tokenization. Let me quickly see if I haven't filed. So the tokenization is nothing but in simple words. Okay, what I'll do is I'll write it here. So today is a good day. Today is a pleasant day, right? So this is the string. So this is the string. Saving it inside an object. If it is in tokenized format, I break down a sentence into every single word. If I'm breaking it to an every single word, it's called as a word tokenization. Today is a pleasant day. So every word in a sentence is being tokenized, right? So it is again, it's separated, it's split into and separate words. That's what you call as a tokenization. The tokenization can be the sentence tokenization, the paragraph tokenization, right? So this is how ends sentence in simple string has been tokenized.
Great. What is JSON format?
Okay. Oh, okay. Maybe what is in JSON? JSON format is a semi-structured format. You can see here. I go up. So it has some JSON has some key value pairs, right? For the word entity, value is 0, 16, and name. JSON is a key value pair. It's in semi-structured data. It's not unstructured, it's in semi-structured
data. Right. There are a few more questions on a little more about speech tagging. I mean, a lot of your talk was around it. Could you want to summarize it?
The speech tagging, you mean POS tagging? Part of speech tagging. I think the speech tagging.
Part of speech.
Yeah. So the part of speech tagging is, again, this is what we were saying, right? So every word, the tokenized word, I'm tagging to what is the grammatical sense, right? Part of speech. What is the part of speech? Like we learned in the high school. What is that I mean? It's a proper noun. Loud mean, it's a verb. In a sentence, what is that each and every word represents? Right? The is a determiner. Screen is a noun. Resolution is a noun. So what is that in a sentence? What is that part of speech tag? What is the grammatical sense of that word in that sentence? That is what the part of speech tag is.
Right. Another very interesting question. Is there all these capabilities that NLP has, is there an alternative to this? Is there an alternate technology that gives this kind of results? That's why Mr. Pratik.
Okay, so alternative, see, so these are the basic fundamentals. How do you process this text, right? If you do not want to process all this text, nowadays there are a lot of open AIs from the Hugging Faces available, right? So the Gen AI is making a revolution recently, right? So we can make use of the Gen AI, you can upload and document, and you can extract the entities right away, right? Because like an Encore web that I'm using here, they're using a GPT models within the data that they are using, right? So if you're looking for an alternative for all this process, maybe a pre-trained model. There are various different pre-trained models. So here what we have used is from Spacey and Encore web. You can use an in GPT 3.5, GPT-4 models, and you can look at as an alternative for all this process, the pre-processing steps.
Right. Okay, another question. This will be the last question. After this, we will conclude. So all this NLP concepts that we're discussing, and I must tell you, it is a very, very clear, crisp kind of masterclass on the fundamentals of NLP. You know, a non-technical person like me also could understand a great part of it. So the question is, where does data science come in all this process? Come into, you know, in all this process?
Okay. See, the word data science is a very huge topic, right? So when you use machine learning, deep learning, right, and text processing, the image processing, video processing. So when you do an analytics, when you do some analytics, and when you do an algorithm, machine learning algorithm, or in deep learning neural networks, it means that you are touch basing on a data science, right? So the Encore web is a pre-trained model. It's a pre-trained transformer based model, right? I'm making use of this model and I'm doing some processing. So the data science is again when you deal something with data, right? So when you want to look for an informed decision from a data, you call it as a data sciences. You do in basic data analytics, you do an hypothesis testing, or you do an sentiment analysis, or an the chatbot. You create a chatbot, or you do an image processing, or in video analytics, video processing, right? So all this comes under the scope of an data. You have some data, and you're making some informed decisions from the data. That's where the data sciences fall into. That's where you call all this as some data sciences. So under the data science, one of the branch is the natural language processing.
Right. Thank you, Sarveshwaran. Thank you so much for spending this one really, really exciting hour. I'm sure there was a lot of learnings for all our audience today. So yes, this is being streamed live on YouTube and LinkedIn. So it is going to be available on both these public platforms. A lot of people are asking for recordings of the session. So for their benefit, you can come back to Odin School's LinkedIn page and YouTube page and watch the video as many times as you want. If there are any specific questions you have, please feel free to post it in the chat. We will do our best to answer as many questions as we can. Thank you, Sarveshwaran, once again. We'd like to have you back for more interesting insights in the future, but
sure.
It's been an amazing learning experience with you. Thank you so much.
Thank you. Thanks. Thank you, guys. Thanks for your time. Thank you.